universities, the Western technical institutions. So they have a very close association with the industry and the technologies, with the research, the technologies which are being developed, the research which is being carried out. More or less, they have an influence on the industry, and industry institute relationship is very, very important. In India also, now we have found for the last few years that academia cannot survive without an industry, and industrial development, the technological development, the research which generally the students do, it should influence the industry. It should help in building up the technologies of which are to be used or which are being used by the industries. So similarly, CNC machining, when we talk about this technology, it can fix many issues in production that cannot be solved by other processes. I think much has been told about it by the earlier uh, resource people, the experts of the CNC machines. Now, a simple question. Usually, precision metal parts are CNC machined, even in the first stage with mold that we know. It will also be machined after molding. So after molding also machining is required. After casting also machining is required. Those of you who have been exposed to industries, so they will find the relevance of machining in manufacturing. It is very prevalent. So we cannot talk about producing a product generally without machining it on some machine tools, on some machine facilities. So CNC is the machine which is used throughout the industries in today's era. Why do we use CNC technology? What is the benefit? So the basic answer to that question is, say after molding, we have a lot of roughnesses. So the to achieve a smooth finish, to obtain a precision, a molded metal parts are quite rough. So we need to obtain a certain uh, precision values, and CNCs turn out to be one of the best facilities for achieving that. No matter sand casting molds or die castings also are used. So CNC machining services, when we talk about, they have several advantages over other manufacturing processes, such as it has been told to you, if we would have been uh, offline, I would ask this question to you. Like I remember the first lecture, Mr. Hafizullah Khan asked a lot of questions to you, but I don't have much time. So you should remember these points, that CNC machining services, when we talk about this technology, they have several advantages over other available manufacturing processes. Like it's cost effective for short runs, more complex shapes and high dimension accuracies are possible with CNC, smooth, polished, finished parts can be easily achieved by CNC. So CNC milling can also make almost any 2D or 3D shapes offered, where the rotating cutting tools can reach the material to be cut off. So that is the advantage. The examples which are commonly used in today's of manufacturing parts, they include engine components, because what we realize that engine components are very complex. Lot of contours, lot of holes, lot of internal machining, lot of external machining is required. So engine components, I think CNC technology is considered to be one of the best technologies for producing engine components. Then molds.
Sir, your slides are not moving, sir. Are
No,
you?
no. I'm still at the first slide.
Okay, sir.
Still at the
Sorry.
first slide. I just want to give the small overview, and then I'll come back to my slide.
Okay, sir. Sorry,
Okay.
sorry, sorry.
So I was talking about the advantages of CNC milling. Okay. Now, what happens with the increasing competition? Now I'll come to the industrial engineering. Why now we're talking about? Actually, what we find that all these technologies, all these the new facilities, the new tools, the new manufacturing capabilities which we have, once they are implemented in the industry, it's very, very important for us to effectively and efficiently utilize them. Otherwise, the whole gamut, the whole narrative of CNC technologies or any technologies is will not be met effectively with more, the objectives will not be met efficiently until and unless we understand that what are the important industrial engineering techniques and how these technologies need to be amalgamated together, how they need to be combined, and how exactly we need to make use of them. So why do we want it now? We know that with the increase in the competition in the market, now let's actually, all facilities are used to produce some product, and all products which are produced by the industries, they have to be ultimately used by the customers. They have to penetrate into the market. So it must have a market. So because the market is very competitive, enterprising the manufacturing industries are facing challenges in the capital utilization, maybe in the production capacity, the quality of the products being produced, the reliability, the delivery, the cost, and manpower utilization. Now, how exactly to achieve them? So, the actual production process associated uh, with so many shop floor problems, basically, they are resulting in low capacity. They are resulting in the quality parameters, that maybe the instabilities and high labor costs, a serious staff loss, and other factors. And that's why industrial engineering need to be understood with the production technology. That's why we say that industrial and production are the two sides of the same coin. We should, if we are an expert in production technologies, in manufacturing technologies, but at the ground level, when we talk about the industries, if we don't combine the techniques of industrial engineering, the whole objectives would not be achieved. The objectives which I told you of quality, cost, reliability, stability, labor utilization, cost utilization, and so forth, which we'll be talking about. So that's why we say that enterprises cannot rely solely on the increase in the equipment. I have 10 CNCs in my shop floor. I have 20 robots working. But no, no, they cannot rely solely on the increase in the equipments, increase in the manpower, working your resources overtime, and so forth to meet the customer requirements, but should rely on scientific management methods to tap its potential. That's very, very important. Is it clear till now? Okay, now the important thing is, when we talk about a facility, when we talk about an industry, when we talk about an enterprise, the important thing which comes in our mind is the value chain. Value chain. Am I clear, sir? Is everybody listening to me?
Yes, sir.
Okay. So the second slide which I'm putting is my slide changed now?
Yes, sir.
Okay, is the value chain, is the value chain. Now, the whole concept of value chain, the concept we call as an input output system. It is very well. Now, let's say we have a CNC machine, a very high end 5 crore CNC machine. The CNC machine can be understood as a value chain. Number one, if you have a shop floor, a shop floor with a few facilities, it can be understood as a value chain. A small restaurant can be understood as a value chain. A manufacturing unit, a small manufacturing unit can be understood as a value chain. A big industry can be understood as a value chain, or any such facility where people like you and me are working, and we have some defined objectives, we have some inputs, we have some processes or network of processes in the center, and we have at the other side what we call as the output. Output in forms of in form of a manufactured product or a manufactured service. So that is known as a value chain. Now uh, the first line of action in value chain is what we in journal we call them as a suppliers. Now, let's see at our CNC machine on which you have done your training. So the CNC, it depends on the suppliers. So who are the suppliers? All the materials which is given, all the materials, all the jobs, all the the consumables which this machine is making use of in its smooth operation, that could be understood as the supplier end. So similarly, when we talk about the industries where we have a number of facilities, number of machines, so they highly depend upon the supply. So this is one of the important ingredients of the value chain, which we call as a supplier. So we have to understand suppliers doesn't mean actually the vendors. It can mean many things to many people. It can mean all those facilities which are used to run a machine, all those facilities which are used to run a particular system, all those facilities, all those people, all those resources which actually give some type of a support system in forms of consumables, in form of raw materials, in form of the semi-finished products and so forth. They have to be understood as the suppliers, number one. The second important ingredient of a value chain is what we call as the inputs. So that this we know, generally we talk about the 6 M's as the inputs, like man, of course woman, machine, materials, then a market, the methods, money, capital. These are 5 or 6 M's generally, which we call, and then we have land, which we are building, a lot of energy which we're using, a lot of information systems, and so forth. So these are the typical inputs of a value chain. And then the third thing which comes is the value addition process, the heart of the core of a value chain system. We call them as the processes or the network of processes. Now this is the where people like you, engineers, would really contribute, where there's a value addition, some type of process is being defined. Now when we look at a CNC machine, a 5-axis DMG Mori CNC machine, now what is the value addition? The value addition is the transformation. It is maybe removing, it is performing some type of operation on a workpiece, and it's adding value. It's creating a kind of dimensions. It's creating a kind of creating some specifications of a certain product, and it's adding value, and with that it adds value to it. And then of course we talk about transformation process. We cannot say that whatever comes in would come out. No, there has to be some change, some element of change, some agent of change has to be in the processes where we are actually performing the operations. So you have seen during your practicals, during your the second part, that how exactly the CNC machine was operated, and how exactly the value addition process, the transformation process were performed by our operator, engineer Nadeem, who has demonstrated you the working of that machine. So this is where actually we have to be focused on as when we talk about the technologies, when we talk about the robotic technologies, the CNC technologies, or whatever facilities which we are using. So that is where the role of industrial engineering, the role of process engineering, the role of manufacturing engineering, or role of any other engineering person is that some type of value addition, and this has to be done effectively, efficiently, with the help of available resources which we talk about in the second stage as the inputs. And then the next ingredient of the value chain is the goods and the services, that what is the output from that machine. And then when we talk about the output, we say that there has to be a feedback system. Some type of checks and balances must be maintained. Some type of inspections must be performed. Some types of quality checks have to be done to conform to the desired specifications, whatever the designer has wished. So yahan par hamara what we talk about is the quality control, and is our product or service coming achieving those parameters for which the value addition process was performed. And then we talk about the post services. So this is what we call as the value chain. Now, in all this, let's try to understand what is the role of industrial engineering, and what is the role of engineers like you when we talk about when we say that we talk about the industries, when we talk about creating a ecosystem of productivity, cost reduction, effective and efficient utilization of resources, stability, high labor utilization, and so forth. So I techniques, industrial engineering techniques, they provide the scientific management methods to optimize. So my friend Dinesh talked about optimization. So what is optimization? You, all of you know about that. So this technique of IE, basically it provides the scientific management methods. So those scientific management methods are there are many and many and many and many new methods also have been developed to optimize the use of resources, monitor and maintain the quality levels of products and services, and then the production planning and control, PPC we call us, the process planning, which are the first day we are talking about the process planning, the scientific integration of all the resources which we talked about, in order to what, why do we want to do it? We want to do it for cost reduction, for increase in productivity, better utilization of our resources, because the resources are scarce. There's a scarcity of resources. Any organization, पूरी दुनिया में, if you look around the world, you name the biggest of the organization, you look at the most resourceful organization, you look at the most affluent management. So they too look at the resources, because there's a scarcity of resources. We don't want to waste. We want to reduce the wastivity. We want to increase the productivity. So we talk about every organizations, they talk about the effective and efficient utilization of these resources. And then they solve many engineering, manpower, and material related problems to achieve a better technical and economic benefits. That we want a better technical benefits. We want better economical benefits. So everything boils down to money. We need to save cost. That's very, very important. As a production engineer, we talked about a cycle time in the machine. As a programmer, you have to write the program in such a way where the cycle time is reduced. Am I clear? Say yes or no.
Yes, sir.
Yes, sir. Everybody is able to listen and understand? Everyone is able to listen?
Sir.
Okay, very good.
Yes, sir.
So CNC is a value addition process. Why I was trying to tell you about the value addition. CNC is a value addition process in the production setup without much human intervention. We understand that also. Okay, thereby improving the man-machine ratio, reduce processing cost and labor needs, improve production adaptability, and production value addition. Okay. However, if you look at the traditional manual operations and management of CNC machine tools, it is still limited by the existing technical conditions, by the production management and the production quality and the technological level, and cannot solve all the problems in production independently and completely. That's why the research, when you talk about the research in IE area, so that research, maybe you can undertake some type of PhD programs in formulating a research problem to how exactly the industrial the current industrial problems can be solved by using management techniques, by using industrial engineering techniques, by using manufacturing and production techniques. Okay, how to write a program in a better way, which type of software should be used for running the machine, because machines do not run independently. I told you that currently the CNC machine, the 5-axis DMG Mori machine, which is available with us, it cannot run effectively with all its 5 axes without procuring, installing, and running a software, SolidWorks, which we have identified. That would actually, that software, if we procure and install, that would make it much more flexible, and all the 5 axes would be used. So that those CAD/CAM systems, CAD/CAM engineering, which we talk about, so they are very, very important. So through the analysis which we talk about of your research, your production research, we understand that the main factors that affect the machines or the facilities, they are the processing cost. This is very, very important factor, processing cost. Then production and quality of the machine tools, the products, the processing technology, the tool life. Someone I remember talked about the tool life, the tool wear. Okay, the personal qualities, the personal qualities, the people who are working, how to improve their efficiency, and then the production management, the workshop production environment also is a factor. The logistics, the workshop logistics, and the production layouts. So these are important factors which must be considered in the whole research, or in the efficiency of the machine. So these factors, they affect each other, resulting in CNC machine tools in the production process, which cannot uh, completely rely on a workmanship of a person who is working there. No, so it has to, other systems are related. They have to play its important role. They have to play very important role. So that's why we talk about the industrial engineering. So what is industrial engineering basically? So industrial engineering is basically, we can say, it is a field of engineering which is concerned with generally three important parameters, which are, that first is the design, installation, and improvement. Design, installation, and improvement of man, machine, and materials. So it's concerned with the integration of all the resources which we are using in an enterprise, especially the 5 M's or 6 M's. Okay, and then these resources need to be integrated. So this industrial engineering is an applied science. It's an applied science which is used for the integration of all the resources to manage our businesses. Whether we talk about the small piece of equipment or we talk about a large business, so there is a role of industrial engineering for improving for reducing the cost reduction, number one. Number two is the increase in the productivity. You understand that also. And number three is the effective and utilization of resources, because resources are very scarce. Scarcity of resources are there. And number four is the man-machine system, to design a man-machine system ergonomically. So those are broad four important aspects of industrial engineering. So industrial engineers, they serve in area that range from the production of raw materials to manufacturing or to service industry. Now we come to the techniques. There are nowadays many techniques. Hundreds of techniques have been developed, and I'm sure that those of you who want to carry their research in this area, industrial and production area, they would appreciate these techniques, and they would come up with the extensions of the available techniques or a formulation of the new techniques. So that's why new techniques are being developed, especially if you look at the Western economies. Look at the Japanese, Chinese, and US, Europe. So they are coming up with new techniques every now and then. You find something new has come in the industry, which would actually achieve those four objectives which I've talked about earlier. So these are some of the techniques, like I want my CNC machine to be utilized properly. So there are 20 jobs which are being currently done, 20 jobs which my CNC 5-axis DMG Mori machine is doing. I should know what is the standard time, because until and unless I don't formulate my standard times, then I would not be able to determine my cycle time. If I am not able to determine my cycle time, I would not come to know when exactly I'm going to complete a particular job. If I'm not able to complete, if I am not able to know when I'm going to complete a particular job, I'm not going to tell my customers when your jobs would be ready. So that's very important. That delivery promises which we make. Okay, the Maruti Udyog says that in the year 2022, we are going to produce 20,000 units of Ciaz car, or 10,000 units of some XYZ car. On what basis I have given those promises? So those promises are given by on the basis of my work study, my method studies. What are the methods, and what are and then the standard times, how much time it is going to complete for a particular job. So this is a very important technique, which we call as a work study technique, where we are able to determine the standard time of a job and then based upon my observed time, based upon my calculations of normal time, based upon the performance of my worker, uh, how my worker is performing, and based upon the allowances which I would like to give to my manpower, I would determine my standard time, and based upon the values of the standard time, I would determine my capacity planning, how many shifts I have to run, what is the demand of the customers, and then how exactly I make use of my technologies. That's very, very important technique. Time will not permit me, otherwise it's a huge topic which is of interest. Then come to the next few techniques. Most of you must have understood and studied these techniques during your BTech in industrial engineering courses. So we have techniques like facility location and layout, supply chain management, inventory control, materials management, production planning and control, the statistical process control, my process planning. It's very, very important. My project management. We have the two important techniques of a project management, which are called as the PERT and CPM, which are used by the industrial engineers, which are used by the mechanical engineers, which are used by the civil engineers, which are used by the chemical engineers when they are managing their projects. Nowadays, if you look, most of the activities in industries are project-based activities. So whenever you have a project-based activities, you have to use some techniques to save the time and cost. And project management techniques are very, very handily used. A lot of softwares have been developed for all such techniques, and then of course they are going to give us a better management systems. Then forecasting, operations research, total quality management, reverse engineering, and these are some of the few techniques which we talk about. Okay, coming to this slide, now we understand the very, very important aspect of a job, that how exactly is my job defined, how exactly is the basic work content and the excess work content. They form a complete important work content dimensions in industries. Whether I talk about my 5 axis CNC machine, whether I talk about the machines present on my shop floor, whether I talk about big industries where a lot of uh, high technological machines are concerned, even then you have basic work content and excess work content. Every system has a basic work content and excess work content. Now it's important for us to understand, there could be some argument. You can also argue that, sir, because of the technological interventions, you have a lot of programming, you have a lot of simulations which happen, and then the work starts. The excess work content is not a major dimension of a work content in today's technology of industry 4.0. But still, then I would say that it's a technology. Ultimately, technologies have to be like engineer Hafizullah Khan the day one said that if you don't write your programs well, if you're not writing the scripts, the G codes, M codes well, then maybe the cycle time will increase. So he gave a very important suggestion to us that, sir, ask your students to, for a particular job, generate programs. So evaluate those small programs and see which program has the shortest cycle time. So that would be the best program. So the skill of the programmer is what actually would give me a excess work content. If I'm not writing my program well, if my operator is not moving my the tool movements well, if the feed rates, if the speed, if all the dimensions to run the machine are not correctly understood, if my designer is not giving me a good design, then the problems would arise and it would basically extend my basic work content. That is what we call as the excess work content. Are you following? Is it clear, everyone?
Yes, sir.
Students, I want the students should answer, the people who are participating.
Yes, sir, it's clear.
Yes, sir.
Okay, good.
Yes, sir.
Okay. Am I shouting or my voice is clear?
Yes,
Yes, sir,
sir.
it's clear.
I don't know how to uh, manage my the pitch. So is my pitch very clear? Okay, good.
Yes, sir.
Okay, very good. Now, for engineers like you, whether you are working on CNC machines, whether you are working on any facility, it's very important for you to understand what is excess work content. Because until and unless you don't understand what is excess work content, you won't be able to do justice with that machine, whether it's a CNC machine or any other technology. Now, generally, in industrial engineering, we presume, we say that the excess work content consists of four dimensions. So, work content can be added due to defects in design or specifications of the products. I hope this you understand. Your designer has not perceived, your designer is not able to conceive the ideas very well. He has not understood the need of the customers, or he has not understood the how exactly a particular product or a technology or a service would meet the desired specifications, would meet the rather the desired characteristics of a product or a service. So this is very important. If there is a failure on part of the designer, we say that the work content is added to the basic work. The basic work content is the minimum irreducible time. Just understand that thing. Basic work content is the minimum irreducible time to produce a part. If everything, we say this is an ideal, everything is done in a very effective and efficient way. So this is ideal, basically. In today's shop floors, we never arrive to a basic work content. There are excess work contents which are added to the systems because of these reasons. Then the second part of it is the work content could be added by inefficient methods of manufacturing or operation. Now, this is very, very important. Again, come to the CNC machines. Now, Mr. Nadeem, Engineer Nadeem, is understanding the drawings. He is trying to help the students, the research students. He's trying to help the industries. They came up with some design, but his work content is added because the methods which he's using, manufacturing method, is not good. Or rather, I would say that there was one professor who came to us, and he told us, sir, please give me these 5 parts manufactured. I've not named the professor. Small pins. So he gave he made a lot of pressure to engineer Nadeem. Please do it. So he came to me, sir, ye chote chote parts and we cannot hold. We don't have a vice. There is no vice available, and it would be very difficult for us to run this high sophisticated CNC machine because we cannot hold this part. But that professor was telling him, please do it. Please do it. I need to be done on this machine. So he was in a fix. So this is important. We have to understand whether this CNC machine is the right machine, whether there is some other simple lathe or a simple milling machine or other machines, other technologies, other processes which would be used for efficient, which would give efficient methods of manufacturing or operations. So here is what is the role of process engineers. So process engineers would understand, give a holistic picture to the process of value addition. And if we are not able to do that, so we are adding excess work content, and that could be because of maybe a wrong machine used, uh, a process not operated correctly, a wrong tools which we are using, a layout is not good, the working methods are not good. So those add to the second part of this access work content. Then the next 2 parts are basically ineffective time. And they are due to the shortcomings of the management. Sometimes they are within the control of the worker. The workers who are available on the CNC machine, on the facilities, they are absent. They're not coming to the duties regularly because of some reasons. They're coming late. They are ideal. They show lack of interest. They are not motivated. They are working carelessly. More accidents are being caused. So the second last 2 parts are more or less management related. They are because of shortcomings of the management due to some factors. Uh, and what are the reasons I have mentioned? You must have read the reasons of these 4 important basic and excess work content. Now, the important thing which I now want to tell you are the quality assurances, because one of the outputs, and a very, very, very important output of a machine, of a technology, is the quality. If you are not able to produce a part which conforms to the requirements, where then the whole activity which we have done is a waste. So if the quality products are not being produced, then what can happen? Either there could be a lot of rework because the inspections are not giving you right report, or there could be rejections, or people are rejecting your part, and then rejections means increase in wastage. So that is very important part of an industrial engineer on whatever machines. So even the CNC machines, if we are writing the right program, we are writing everything in a correct way. But at the end of the day, we find due to some reasons, what are those reasons, which I would tell in the next slide. We are not able to generate the correct dimensions, the correct specifications, the correct tolerance limits, which all of us know. Then all the activities, all which are done on the machines, on the technologies, are waste of time, waste of resources. So quality assurance is a very important dimension of industrial engineering, where the industrial engineers, the manufacturing engineers, the production engineers assure that our facility is used in the best of its uh, capabilities, and a right quality product or service is being generated. Uh, the various phases of this quality assurance start from in acceptance sampling. That means that we are inspecting before and after the production. So the acceptance sampling is purely based upon inspections, but this is a uh, this is what we call as inspections, descriptive way of controlling the quality. Now there are objective ways of controlling quality, which we call as a process control. So these are based upon the scientific principles, like the corrective actions during production. We don't want to control, we just don't want to inspect and see how many good parts are there and how many bad parts are there. No, we want that our process, the core of our value addition, the process should be run effectively. Until and unless we are not running our processes effectively, then more bad parts would be generated. There will be more bad parts which would be produced in our value addition process. And that's why the corrective action has to be taken care of. And now this is a very progressive technique we call as a process control technique. And then the most progressive is what we call as a continuous improvement. And this most of you must have read about the JIT technologies, just in time, and then total quality management, and those evolving technologies, management techniques, where we want to that zero defect. A lot of schemes have come up, zero effect, zero defect. So quality built into the process. We are trying to build the quality into our manufacturing process, so that the quality assurance is guaranteed, and we are able to produce good parts. The important thing which we need to understand now is that what could be the source of variation. Mr. Nadeem is running his machine. He has done everything perfectly, but still he finds that if he is manufacturing 20 parts, there could be variation in all these 20 parts. So the sources of variation are the variations exist in all processes. The first important thing which you have to understand: no technology in the world, in this globe, is a technology where all 100 parts, say for example, would give me the same dimensions. No, there would be variations. There would be variations. Now, if I ask you a question, let me ask a question to: what are the sources of variations? What are the sources of variation? Who can tell me? Yes. Lakshmi Kala is there? Oh my God, where is everyone?
Yes, sir. Yes, sir. Yes, sir.
Lakshmi, can you tell me what are the sources of variation?
Sir, maybe the dimensions, sir.
Generally in industry.
Environmental causes.
Okay, good.
Systematical errors like say random variations.
Random variation. Very good. Irfan bin Ashraf. Oh, sorry. Irfan is a host. Mohammed Rafiq. Where are the
Yes, sir.
students?
Yes, sir. Yes, sir.
Mohammed
Sir,
Rafiq.
there could be like poor these employable these training peoples who are poor in like working, who are not trained well. There could be errors in like machining tools, sir. Those could be some variations for that, sir.
Okay. Now, important thing which you have to understand, all of you, is that the sources of variations can be understood in two ways. One is that we call it the common or random causes of variation, and the second is the assignable causes of variation. Right? What are the random causes of variation? Random causes are that which cannot be identified. Eventually, a worker, engineer Nadeem, has no control over the random causes of variation. They are unavoidable. The reasons why these causes are there may be a slight difference in the process variation, like diameter, weight, service time, temperature, or it could be because of some there's a backlash, a gear backlash within the machine, or some factors which are unknown, uncontrollable, and then that is the reason where we have eventually no control, and we call them as the random causes of variation. But important thing for us to understand is that these random causes of variation, the range or the standard deviation should be equal to how much what should be the standard deviation? Who can tell me? शाबाश शाबाश शाबाश. ये जो रैंडम कॉजेज ऑफ वेरिएशन है एक सिस्टम में, इनकी व्हाट इज द एक्सेप्टेबल लिमिट टू दोज? यू आर ऑल मास्टर्स लेवल स्टूडेंट. तारिक अहमद,
Yes, sir.
ये जो रैंडम कॉजेज ऑफ वेरिएशन है इनका रेंज क्या होना चाहिए? व्हाट शुड बी द स्टैंडर्ड डिविएशन?
Sir, I cannot say anything because I didn't understand.
Sky Buddy is what I'm getting. Sky Buddy. Who is Sky Buddy? Mahmoud Rafiq Pare. इरफान बिन अशरफ. इरफान साहब आप ही बताइए. लक्ष्मी, कैन यू टेल मी? Deepak? Nobody is here. Where are others?
What is your question, sir?
What happened? What आपने तो मुझे निकाल ही दिया. What happened? Hello?
Yes, sir. You are audible, sir.
Acha, there was some problem. Okay, now just remember, this is very, very important. The random causes of variation must be plus minus 3 sigma. Plus minus 3 sigma is the standard deviation. So whatever value which we have, a process may, every process has some mean. When we are inspecting, when we are generating data, we have the values of mean, mode, range, and then standard deviation. So plus minus 3 sigma is commonly we call them, if your parts which you are manufacturing, or if your a particular dimension, if your particular quality characteristics lie between plus minus 3 sigma levels, we call that as a random variation, and nothing to worry, and that would bound to occur. वो होगा हर एक सिस्टम में. आप you take CNC 5-axis machine, you take any technology, any machine, whenever you produce the items and you inspect them, you generate a data, you say that, based upon the sampling inspections, the sampling inspections which we conduct, and we calculate the value of your sigma, and we calculate plus minus 3 sigma, those your all your quality characteristics would lie in that value. Understood? Yeah, समझ में आ गया आपको?
Yes, sir. Yes, sir.
Very good. Now we come to what are the causes of then variation? We call them as assignable causes of variation. Both important cheese hai. So causes that can be identified and eliminated. Now, Mr. Nadeem is working. He's getting some parts, and the inspector who's inspecting, he says that no, these are not as per the dimensions. It is crossing the plus minus 3 sigma, और आपने जो आपका टॉलरेंस है, आपकी स्पेसिफिकेशन है, उसको ये लिमिट क्रॉस कर रहा है. So that is assignable causes of variation. So you say that as an engineer, ये slide आपकी आ गई, investigation into the assignable causes.
Yes, sir. Yes, sir. Yes, sir.
As when we investigate, we find that there could be two reasons. A reason could be, suppose in a sampling data, we have calculated the mean position of our samples, mean positions, and you have also calculated the sigma, the dispersion. The change, the reason of assignable causes could be that there is a change in the process setting. When we say that the process setting change ho gayi hai, it means that the mean of the distribution has changed. This is number one. The second reason could be that there's an increase in the process dispersion. The sigma value hai wo increase ho gaya hai. It has increased, not decreased, it has increased. If I ask you a question, if there is a decrease in the process dispersion, what does it mean? Who will answer that question? Anyone? Within 3 seconds? No one. So the decrease in the process dispersion is a good sign. It means that our process, हमारी जो machine की processing है, Mr. Nadeem is doing very well, और उसने dispersion कम कर दिया है, उसका sigma का value बहुत कम कर दिया है, and we are able to produce parts of high quality, of high quality within the specification ranges. So now what are the reasons? The reasons for change in the process setting or the mean, if you find that the mean of the distribution changes. They could be because of number one, tool or die wear. अगर आपका tool wear हो गया है, so you're using your machine for a long time, or it's not being used correctly, there are some then accuracy issues, there are some machine setting issues where it is causing tool or die wear. So once there's a tool and die wear, this could lead to assignable causes of variation. Then number two, it could be because of minor failures due to the wear of the machine components. Again, some old machines, or the machines are not being maintained properly. Maintenance activities are not being done correctly, or the machines are being mishandled. As I told you, someone told Nadeem, please, आप छोटे-छोटे parts manufacture करो इस machine में. Nadeem घबरा गया. He said, I don't have voice. If I make use of a voice, that might disturb the accuracy of the machine. Machine की accuracy disturb हो जाएगी. Machine के there could be some minor failures because of wear of the machine component. Machine wear हो जाएगा. So this is the second reason. The third reason could be change of the machine. Now in production settings, you have three CNC machines. Now एक particular job को आप पहले एक machine पर करते हो. Then the shift changes. The second person comes. So this could also lead to what important. I will give an example in industries long back when things were not evolved, research was not evolved. I think it was in the 80s. Perhaps that was there were 5 or 6 machines which were put on one shop floor. So इसकी जो proximity थी वो बहुत पास थी. Maybe the machines were kept at a distance of hardly a couple of meters. So when the new machines were installed and then the job came on those machines, it was found that one machine, the operator was excellent. He was a very trained operator, but every other parameters were correct, but still the parts which he was producing was not up to the specification. So there was a lot of investigation. A lot of engineers came and they brainstormed what could go wrong. The machine maintenance staff was called and everything was checked. It was found that सब तो ठीक है यार, ये क्यों हो रहा है बार बार. We are able to बार बार every time when we are going producing a new part, the same problems occur. And then suddenly they found that next day the machines which were in the vicinity, which the machine is mounted.
Sir, you are not audible, sir.
Transformed to some other part. Am I audible? Is it clear?
Sir, sometimes the voice is breaking, sir.
The voice is breaking. I was talking for the last 4-5 minutes. Does it make sense? Have you understood what I was saying?
No, sir. Actually, the voice was breaking, sir, continuously.
It was breaking. For what reasons? I don't know. These are the glitches, common glitches. Okay, that's why online is a very cumbersome process. I was trying to explain you that hello, am I audible? Am I audible?
Yes, sir, you are audible now.
Oh, there was a glitch. I think something went wrong. So I will. Is my slide visible?
Your screen is not present. Sorry.
Okay. So is it visible now?
Yes, it is visible now.
Okay, just say yes or no. Keep on saying yes, yes, yes. Otherwise, I don't know when exactly you are in and when there's a glitch in the in this technology. So the machine vibration. I was trying to give you an example of the machine vibrations. What is the role of the machine vibrations? So I was trying to explain you with an help an example that few years back, perhaps in 80s, there was in a HMT machine shop. There were 4 or 5 new machines which were installed for a particular process, and then all the machines were installed and they were working. In one particular machine, it was found that every time a particular part, when it was produced, the dimension accuracy was not being achieved. So when the investigation was carried out, when the inspectors came, they measured the part. The maintenance staff came, they observed, they tested all the machine components. They found that everything was put rightly. There was no problem with the machine. Still, then there were bad parts. Parts with poor quality, not meeting the desired specifications, which were coming out of that machine. So the next day, what they observed, that the machine which is in the vicinity, that was not working because that operator was absent. And during that day, when the same parts were produced, they conformed to the specifications, and that's how they came to know that the vibrations, the machine vibrations, they play a major role in disturbing, in creating an assignable causes of variation in the system, in the machine. So similarly, I told you that if you look at today's machine, the CNC 5-axis machine which is installed, it has special special pads which has been put at the base. So those are the what we call as the vibration absorbers. They absorb the vibrations which are created by the machines, so that these vibrations do not pass to the next machine. So even we should have a very strong base. The machine base has to be very, very strong. And until and unless the machine base is not very strong, the machine which is at the vicinity, the parts which are produced in that machine may inculcate some assignable causes of variation. So that's the importance of a machine vibration. Is it clear? Have you understood? Hello.
Yes, sir. Yes, sir.
Okay. Then the fifth reason is maybe the change the material properties. Now, what we find that in production setup, in any production setups, if we frequently change the vendors, if we frequently change the suppliers and different suppliers or the suppliers who are giving the raw materials or the semi-finished products in lots, there is a variation from one lot to another lot, or there's a variation of the same material from one supplier to another supplier, because of the reason that the material properties might get changed. So because of this change in the material properties, what we find that the assignable causes of variation could creep into the system and not produce a part of which meet the desired specification. So this is another important reason. Then of course, you know that someone told me just now there's a change in the environmental conditions, and then error of measurement is very, very important. When engineer Nadeem inspects his part, he ensures that the vernier caliper or the micrometer or whatever measuring instrument he's using, it is correctly calibrated. The calibrations have to be good. And sometimes, the measuring of a particular dimension, if we are not using a right measuring tool, or if you are not using a calibrated tool, there could be some errors of measurement, and that could be one of the causes of the change in the mean of the distribution. So this is one set of assignable causes. The second set of assignable causes, as I told you, that the value of the sigma would change. By change, I mean to say the value of sigma has increased. So you understand why it increases. I asked you a question: if the process dispersion decreases, what would happen? I want the answer once again from you. If the process dispersion decreases, what could happen? Shabash.
I think, sir, these random variations would be decreasing, sir.
Yes, those is the value of sigma, because I told you the variation of a random variable is plus minus 3 sigma, and I give you a reason why it's plus minus 3 sigma. So if the sigma is shortening, if your the process dispersion is decreasing, it's a good sign. It's a sign that the process the machine is well in control. There are no assignable causes present, and we are improving on the quality of our products being manufactured. So some of the six causes of this increase in the process dispersion is the machine has deteriorated over time. Okay, maintenance is not taking place very frequently, and then the second reason could be maybe there's an operator who is new, who is not very comfortable with the adjustment process of the machine. He's frequently making readjustments of the process. Okay, so process engineering aapke paas it's not in place. A process engineer has not given you the operation analysis and routine cards. He has not understood the drawings. He has not given you the correct process for operating. Then the third reason could be the variability of the process. The variability of the process has increased. It could be sometimes we find that a new operator or an inexperienced operator is running a particular machine. It could be that sometimes there's a kick. An operator is working very careless. He's not very careful with the process. Carelessness is there vis-a-vis the operator. He's not motivated. He's not giving the right. He's not being given the right incentives, or his training is very poor. He's not being trained. His experience curve has not obtained. That could be the reasons that assignable causes of variations could be present. Now, important thing is that, as I told you, example which I gave you, that we have to ensure that the process capabilities are studied for each process. So every process has what we call as a process width. As I told you, that the process width with most of the German processes is plus minus 3 sigma. So if you look at the sample reports which are being generated, say for example a sample of 20 parts are being inspected randomly, and we are obtaining a mean value and a standard deviation. So plus minus 3 sigma would give me a process width. It would give me a process width. So this process width is what we call as, it lies between the two limits, which we call as the upper control limit and the lower control limit. Now, once this process, a design width is greater than the process width, there could be a possibility the designer has given a given tolerances, or it has given the width of the two limits, the upper limit and the lower limit, in such a way that it has crossed the plus minus 3 sigma, and the specification limits given by the designer is shown by the red line here. So this is lower specification limit and the upper specification limits. So what would happen? What would happen? So this study is very, very important. So I cannot tell Mr. Nadeem or Engineer Nadeem that you produce a part with an accuracy of 3 microns or 4 microns, because I know the day one I told you that the accuracy of my machine is 6 micron. CNC 5-axis DMG Mori machine, its accuracy is 6 microns. So if I have a designer who is giving me a part to produce with 2 micron accuracy, should I be able to do that? No, I might not be able to give those dimensions to that part. So that's very important. In shop floor, where we have hundreds of machines, where we have a lot of CNC machines, milling machines, other machines available, I need to understand who is my designer, what are the specification limits which are given by the designer, and that is what we call as the process capability. So our process capability is nothing but is the ability of my production process to meet or exceed preset specifications, those specifications which are given by the designers. So generally there are some capability index. I am sure that you must have done it in your earlier degrees in your BTech, that we have process capability index, which we call as CP, which is computed. It's a ratio of the specification width. If I'm able to calculate the ratio of my specification width to the width of the process, I would able to find out those values, and based upon the value, I would determine whether this machine is capable or it is not capable. So those are the studies. So what you see here in the first part of this diagram, we say that when your CP is less than 1, when your CP is less than 1, so what we find that there are more bad parts being produced in these areas, extreme areas. Okay, so this is because of the reason where my lower specification limit and the upper specification limit of my designers cross my plus minus 3 sigma limit, and that is the case where my CP is less than 1. The 6 sigma process spread is greater than the tolerance. In the second case, in the case B, is this slide visible to you, all of you?
Yes, sir.
Very good. So यहाँ पर मैं ये देखता हूँ कि my process capability is equal to 1. So what does it mean? It means that the 6 sigma process spread is equal to the tolerance. जो आपकी tolerance designer ने दी है, एक design engineer ने दी है, मेरी process की capability उतनी है. So if the process is perfectly centered, अगर मैं अपने process को Mr. Engineer Nadeem, I call him, is perfectly taking care of the assignable causes. He knows what are the reasons for my assignable causes. He's centering the process perfectly at the mean. So I would not obtain too many bad parts. So we say that 0.3% of the output will be defective. Only it would be 0.3%. So यानी कि ये area जो है, the area which is here, small area plus this small area at these two extremes, their proportion would be not greater than 0.3%, which is acceptable. Okay. And then the C graph, if you see, if my process capability is greater than 1, if it's greater than 1, okay, that means it's a very, very good sign. The 6 sigma process spread fits inside the tolerance with room to spare. I have a lot of room to spare. So the process is highly capable of producing if any defects. So most probably very, very, very few defects would be there in the process. Now, but again, I have to engineer, Nadeem has to center my process to the CP value. So the CPK, there is another index which we call as CPK, is that area where we are producing some bad parts. So this is how exactly CP and CPK is calculated. We call it the CP is the process capability ratio, whereas CPK is a process capability index. So these two are very, very important for any engineer, any CNC operator. That the designer and the design engineer and the production engineer, they have to come together and they have to sit and they have to find that my CNC machine, my CP, what is my value, CP value and a CPK value, and based upon these indexes, the value of these indexes, I would make a decision whether I would run this part, this operation on my 5-axis CNC machine, or I would use some other process to run my machines. So these are what we call as the process capabilities. So this is how exactly I have explained you the four things which can happen. CPK is 0, it's 1, it's negative. It's now very quickly, another 5 minutes I would take to give you some of the important what we call as the advanced manufacturing technologies and systems which you are using. Well, most of you would be familiar with. Now this concept is what we call as a just-in-time concept. It's a Japanese concept and a very, very important concept in industries, where I would ensure that all parts are produced on time, whatever time is limited. The again reason is that this also is called as a zero inventory concept. Just in time is divided into two parts. The first is called the JIT purchase systems and the JIT manufacturing systems. In purchase systems, just in time concept was given by the Japanese industries, and it's being used very prevalently in today's industries all over the world. So they are addressing the challenges of coordinating successive production activities. So because we know in the supply chain, when we talk about supply chain, right from the onset to the last process, the supply chain is well connected to each other. It's well connected. The other day we were talking about the flexible manufacturing systems. We have FMS systems. In FMS, we say that we are using technologies for not only for production but also for material handling, inspections, and so forth. So since now these are well connected from the onset to the last activity, the last process, we have to ensure that even not a single process in the supply chain gets disturbed or it's overburdened. If it gets disturbed or if it's overburdened, by overburdened I mean to say is that it is taking more time. The problems of line balancing are there. You understand that line balancing, it is very, very common problems in industries, in today's industries. So we have to use some heuristics. There are some, because once we talk about the optimization, line balancing optimization problems are very, very difficult to achieve. So we there are some very beautiful heuristics which give us a close to optimization values. So those heuristics need to be inculcated, they need to be put, and then we have to balance our lines, all the processes, the various working centers, working stations, they have to be coordinated and synchronized with the previous and the next work center. And that is how exactly the concept of JIT plays its role in manufacturing. So it's a system to optimize processes and procedures for continuous pursuing waste reduction. So JIT is also a tool where we are able to reduce the waste. Now, what kind of waste, if I ask you a question, what kind of waste are generated in industries? Who can answer to me? This is the last question. How many waste are generated in industry? Dinesh, I'm not very late.
No, sir. We have 5 more minutes.
We have
There are,
Yes, sir. We have 5 more minutes.
5 more minutes. I'll
Yeah.
just include 5 minutes. Yeah, who can tell
Yes,
me
sir.
very quickly?
sir,
What
there are
type of?
so many wastage that produced by industry.
Very good. Let's come to
Uh,
those
for,
waste. Okay. Overproduction
first,
waste. Waiting
first
time
is
waste.
raw material wastage. Second is
Very
part
good.
broken wastage,
Very good.
and third
Excellent.
is
Excellent.
chemical wastage. Fourth one is industrial hazards, which
Excellent, my dear friend. Very good.
might
Very
be
good.
parts or so many others.
Very good, my friend. Very good. Shigo has given 7 ways. You should remember it. These are these again is a Japanese concept. Shigo's 7 wastages. So look at those 7 wastages. If you do not, as an engineer, understand these waste, you won't be able to do justice with the manufacturing engineering or industrial engineering. That's very, very important. Overproduction waste. So this is not only the role of a industrial engineer or the manufacturing engineer, it's the role of the overall management, that we understand what are the production activities which need to be carried out. So if we are doing underproduction or overproduction, this overproduction could give rise to waste. Then if I have to wait, if the man has to wait, if the material has to wait, if the job has to wait, then there is a wastage of time. So waiting time waste, we call it waiting time waste. Okay, we address it by queuing theory. Then we have transportation waste. So if unnecessarily I am handling my materials, materials are being moved from one part to another part without an objective. So transportation waste, unnecessary material handling, or not using the correct transportation means, that could be one of the waste. Then processing waste. Engineer Mr. Nadeem has to look at his machine, at his CNC machine, that what sort of material removal have to be done, what should be the thickness of my of my cut, how much material should be removed, and then someone has to give that what should be the blank size. The management has to ensure that a correct blank size should be given to engineer Mr. Nadeem, so that he doesn't has to excessively remove the material. So processing waste is there. Then we talk about the stocks, the wastages in inventory management, where a lot of wastages take place because of inventories. Because what we need to understand as production engineers, manufacturing engineers, and industrial engineers, that inventory is a necessary evil. Why it's necessary? Because in today's era, we need some inventories because inventory act as a cushion, as a decoupling link between the demand and the supply environment. But keeping too much of inventories would give rise to wastage, the wastage of stocks. Okay? Because inventory, to maintain inventories, to carry inventories, there is cost which is involved. That's why we call it as a necessary evil. And then unnecessary motions. People are moving. Even in industrial engineering, we understand, we study about the motion economy. The method studies. Okay, micro motion economy, micro motion studies are there. So basically, we don't want that any type of movements and motions. Defective products itself is a wastage which we talked about. So these are important 7 Shigo's wastes, which are very, very important. And then the other parameters are zero inventory concepts throughout the value chain, questioning each and every aspect of stock based on the pull rather than push system. So these are 2 technologies which we are generally using: pull technologies and push technologies. In push technologies, we try to innovatively produce a product, and then we try to market it. But in the pull technology, we have a demand. In push technology, the demand is not defined. There is no demand, but you have to create a demand. So your marketing people, after you manufacture a certain design or a product, that has to be pushed into the market, and then it has to be commercialized. But in the pull systems, we have the demands available. Like we manufacture cars, the demand of the cars are there. That's why we do that. So based on the pull system rather than push, the pull systems are very, very important. But now when we talk about having too much of variety, and then change the customer's taste, and then innovations. I'm dealing with innovations. We try to innovate new products, and then based upon those innovations, we try to push those technologies, those products, those services in the market. But for that, you should have a strong marketing team. So that's very important, that generally in manufacturing, pull technologies, the pull systems would really help to minimize the cycle time and to get better profits. So the basic JIT systems, I would just skip it. You can read it of your own. Then the last thing which I'm going to talk about is the computer aided process planning. This is the one system's computer aided process planning, where a lot of things are being done. And then, so basically, you see, we have a variant cap system where we have computer files contain a standard process. आपका जो process है, जो standard process है, so you have computer files जिसमें ये process आपका store है. So एक part अभी manufacture करना है. So you have what we call as a code number. 1 second, sir. Hello. अदावर जी सब जी बिल्कुल ठीक ठाक. हाँ, वो हमारा स्टार्टअप है, उसने किया होगा जी. या वो हमारा है ना, वो इनायत, आप जानते हैं उसको, मूव बियॉन्ड, उसका वर्कशॉप है, एक डीएसटी का वर्कशॉप है. सो से ही हैज मेल्ड हिम फॉर, क्योंकि उनका भी रोल इंपॉर्टेंट है, देयर रोल इज आल्सो देयर. तो वो खुद तो नहीं आएंगे, बट दे कैन सेंड समवन. अच्छा, चले, बहुत अच्छी बात है. वेरी गुड, वेरी गुड. इफ दे कम देमसेल्फ, दैट वुड बी रियली ठीक है. ओके, देन यू सी क्या होता है इसमें, जो वेरिएंट कैप सिस्टम है, वी हैव कोड नंबर. एवरी मैन्युफैक्चर्ड पार्ट और एवरी पार्ट इन इंडस्ट्री, इट हैज सम कोड नंबर. ठीक है. सो वी हैव अ पार्ट फैमिली फाइल, इसको हम बोलते हैं. देयर इज अ फाइलिंग सिस्टम व्हिच इज कॉल्ड एज अ पार्ट फैमिली फाइल, एंड कोड नंबर्स आर जनरेटेड. देन सर्च पार्ट फैमिली फाइल फॉर कोड. वो कोड आप सर्च करते हैं. You retrieve the standard process plan. A process plan जो होता है, this is there in the standard processing plan file. You have a standard process plan file, and then if you want to edit the existing plan or you want to write a new plan, you can do it from the standard process plan file, and the process planning generate होकर आप you can start its manufacturing. This is one important thing. The second, generative, we have a generative cap systems. In generative cap systems, the process plan होता है, there is automatically generated on the base of logical procedures. There's a logical procedure. So process plan जो होता है, that is automatically generated. When we talk about the complex systems, they must contain comprehensive and detailed knowledge of the part shape. क्या आपका part shape क्या है? What are the dimensions? What are the process capabilities which we just talk about? It's very, very important. Okay. Then what are the methods of manufacturing? What is the sequence? What is the machinery and the tools which are required? So these are some of the inputs to the cap system, generative cap systems. Then we have expert systems, which is a computer program capable of solving complex problems. So this is the important of computerization, जो आपकी आजकल की computerization है. So this is the two types of variant cap systems and generative cap systems. I think I should stop here. There were some important. I would share this slide to you now. What was the development of the SIMs? What are the technologies which we are using in current industries? What are their features and their applications? So we know something about the computer-aided engineering and the computer-aided manufacturing. So what are the various ingredients to them? Like we have computer-aided process planning is there, computer-aided planning is there, then quality control is all computerized. So look how exactly things have evolved, and आजकल nothing comes without a software. जितने भी industrial activities हैं, you have some sort of softwares, all computer. That's why CNC technology is all computer. We are not in the industry 1 or industry 2. This is industry 4. Industry 4 is the cyber. Now we are using cyber. Industry 3 was computerization, but it's all internet, the internet of things, IoT, artificial intelligence, big data. Everything is managed with the help of those techniques. So CAD CAM engineering is an important ingredient of a CNC, where we have a lot of systems relating to computers. And then lastly, I think that's enough for me to tell you, because we have increased the time. Thank you so much. If you have any questions, you can write to me, email me, that any queries. And at the last, I would tell you that manufacturing engineering, production engineering, industrial engineering, industrial management, they are a very, very, very important component of the industry of today. when we talk about Industry 4.0. So without these techniques, without these technologies, without these tools, our industry is irrelevant. And as a student of the engineering students, if we do not understand these concepts and we want to create a facility, we want to create a an industrial setup, it won't be possible because of the intense competition, and we have to produce a part which competes as far as the cost is concerned, which competes as far as the quality is concerned, which competes as far as the reliability is concerned, which competes as far as the flexibility is concerned, and many other parameters which we talked about in the beginning. They are very important. So I hope that with this 1.5 hours of discussion, you would try to have a overview of the intense application of manufacturing and industrial engineering in the field. Thank you so much. You have any questions, you can ask me or write to me. Thank you.
Sir. Good morning, sir. Hello.
Hello.
Sir, good morning, sir.
Okay, welcome.
Hello.
Hello.
Sir,
Hello.
Sir, I have one doubt, sir.
Yes.
Sir, shall we call the CNC machining as advanced machining process or advanced manufacturing, sir?
Machining is a part of manufacturing. There is nothing difference in machining and manufacturing. Without machining is a subset of manufacturing.
Okay. Sir, but
See,
what is the
manufacturing,
difference?
we have different manufacturing processes. So machining is also a manufacturing process. Professor Noor is here. You want to say something to this question, sir? Okay.
Actually, it's completely on manufacturing. It's not about just machining. You can go for plenty of operation with CNC. It's actually a manufacturing center. So
yeah,
it's possible. Everything is possible with CNC.
so I would just call the director. I think he should.
Yeah.
गुड मॉर्निंग सर. सर 2 मिनट के लिए सर प्लीज काइंडली हमारा वो क्लोज कर रहे हैं. सो आपका 2 मिनट का योर टाइम इज 2 मिनट्स आर रिक्वायर्ड. जी सर वो मेल मैंने आपको किया था, उसमें सर वो लिंक है. हम परसों किया था सर. सर दोबारा कर दें. जी ये फ्राइडे को किया था सर. फ्राइडे था ना वर्किंग. फ्राइडे को हमने आपको रिक्वेस्ट मेल भी डाली थी सर. जी सर. जी सर बस 5 मिनट सर. Okay, sir. Thank you so much. So the honorable director has joined. Dinesh.
So good morning, everyone. Welcome to the valedictory section of self-sponsored high-end workshop on 5-axis CNC machine. To start with the session, now I request Dr. Noor Jamam Khan, Assistant Professor Mechanical Engineering, to deliver the welcome address.
Thank you, Dinesh. And good morning and welcome to the valedictory function of high-end workshop on 5-axis machining center, organized by Department of Mechanical Engineering and IID Center of NIT Srinagar, under the scheme Karyashala, sponsored by Science and Engineering Research Board, Government of India. And it's with great privilege that I welcome Professor Rakesh Sehgal, Honorable Director at NIT Srinagar, and Professor Sheikh Nazir Ahmed, Workshop Convener and HOD Mechanical Engineering Department, and Convener Professor Saad Parvez, Head ID Center. So we are very honored by your presence, sir, in this function. And, I sincerely welcome workshop coordinators Dr. Dinesh Kumar and Dr. Mohammad Mohsin, and the workshop co-coordinators Dr. Abhijit Dey and Dr. Deepak Naik, and the entire organizing team of the workshop. And I also welcome all our esteemed participants to this valedictory function. And as one of the coordinators of this workshop, I take this opportunity to thank you all for your active participation. And I'm happy that the Department of Mechanical Engineering and ID Center organized this high-end workshop on 5-axis machining center. And I believe that the speakers, experts who have shared their research, their views with us, and interaction that has taken place over these days, it will help us in developing the skills in the area of CNC operation and programming. So once again, I welcome everyone to this function and thanks for inviting me for the welcome address. Thank you.
Thank you, sir. Thank you so much. Now I request Head Mechanical Engineering, Professor Sheikh Nazir Ahmed, to say few words about the workshop. Over to you, sir. Sir, you are muted, sir.
Yes.
Am I audible?
Yes, sir. Yes, sir.
Honorable Director, NIT Srinagar, Professor Rakesh Sehgal, the organizers of the workshop on high-end 5-axis CNC machine, head of the center IIED, Dr. Saad Parvez, Dean Research and Consultancy, Professor M.F. Wani, Registrar NIT Srinagar, Professor S.K. Bukhari, the organizers of the program. It is our great privilege that we have been able to organize such a high-end workshop on 5-axis CNC machine facility and operation. In fact, we have got the talented people in our department like Dr. Saad Parvez, Dr. Noor Zaman, Dr. Mohsin Khan, Dr. Deepak, Dr. Dinesh, and others who are capable and able to deliver such a workshop from National Institute of Technology, Srinagar. The facility has been acquired as central research facility for about 5.5 crore rupees, and this has really enriched the capability of the production engineering department. We have a very powerful materials science division in which material characterization and material development research
I'll call you back.
is department. The department is offering the facility and opportunity. I hope that the participants have been given a very good training on the machine, and they are well enlightened with the aspects of machining by 5-axis CNC machine facility. And after acquiring this short training, they will be, their vision must have been opened, that they are now capable of understanding further uh, in this field, and they are able to handle such facilities. They are going to benefit to their sponsoring organizations, and they will add value to their knowledge by participating in this workshop. And I hope that this workshop has been very successful, because we had the experts and we had engineer Zafar Saab, who was a very senior, talented expert, who to whom we had invited for this workshop to deliver the lectures. With these few words, I thank to the patron, Professor Rakesh Sehgal, the Honorable Director, National Institute of Technology, Srinagar, and the organizers of this workshop. Thank you.
Thank you, sir. Thank you very much for your wonderful words. Now I request Dr. Saad Pavez, Head IDC and the man behind this workshop, to say a few words about the workshop. What do you, sir?
Thank you, Dr. Dinesh. Honorable Director, Dr. Professor Rakesh Sehgal Sahab, respected Head of the Department, Professor Sheikh Nazir Sahab, the Registrar NIT, Kaisar Bukhari Sahab, Dr. Dinesh, Dr. Noor Zaman Khan, other colleagues, friends, and dear participants. A very good morning to all, and I hope that this workshop must have given you the insight of the CNC technologies, and especially the 5-axis technologies. And then I'm very thankful to all that all participants very dedicatedly participated in it, and then we had a wonderful resource people. I'm sure that there must be a thorough value addition in the CNC technologies. Now, this is the first of the workshop and training program which IED Center along with the Mechanical Engineering Department had conducted, but conducting such a workshop online is not doing justice to this, hello. There was some glitch. So as I was saying that the IED Center is planning to conduct at least two to three training and skill development workshops every year as far as the CNC 5-axis machines are concerned. And I hope that this is not the baby of IID Center only. All the stakeholders, whether they are from the different departments, the honorable director, the registrar, the administration, the accounts, everybody has to participate. It has been a teamwork, or it is going to be a teamwork. And then the main objective of this machine is not only skill development and training. It's the second important objective of procuring this machine was to enhance innovations. So this machine would be open for any innovative ideas, whether they are from the local NIT students or the students from different colleges and institutions, or any other innovator who has a very complex shape he wants to manufacture and is not able to do it with ease. I think this machine would be one of the facility which would do it with ease, and we are hoping that innovations thrive in this region as far as producing parts are concerned. And then as engineer Hafizullah gave a very good suggestion to us, that this machine would be used by the students to generate programs, because if we have good programmers, if we are able to generate good programs, CNC programs, I think their employability will definitely go up. And you see, this technology would really help the students to increase their employability. There are thousands of industries in the country, thousands of industries where CNC technology is being used. And then if during the campus placements, during the interviews, our students are able to convince that no, he can write a program, he can operate a machine, or he knows about the CNC technology, I think his chances of getting selected would definitely go up. And that is what we are looking. The training and placements of our students would be enhanced with the help of this facility of the institute. And then the two more important components of procuring and installing this machine is the industry and the research components. I remember that few years back, there was an industrial person who came to me who has a unit called as Al Crystals. So what he told me that he has a particular tool which he's using in industry, which he wants to machine. It was a complex shape, but we tried. He went to different industries located in the vicinity in this region, and then he came to our workshop, but none of the people or none of the facilities could do that machining of that tool which he's using in industry. So with this technology, I'm sure that any complex shapes of the tools of the industries, of the jobs of the industries, of the any such parts which the industrial wants to produce within the valley, we would be able to do it. And then he would be saving his cost and efforts to produce dies, tools, and such, products where he has actually to go out either to the Punjab belt, or even sometimes I found that those industries people, they have to send their small tool which needs some type of machining to different countries abroad. So in that way, they had to spend a lot of cost and efforts. I am sure that in the future, once our operator is highly skilled, he becomes a highly skilled operator, and then such industrial work we will be taking and generating the revenue, the internal revenue generation would be there, and then we would be able to help our local industry. That is also one of the motives. And the fifth and the last important motive of having this facility is that our research students should get benefited out of it. I know that now it has been more than 6 months. There are many research students who are coming to us with their jobs, and then we have helped our operator, Dr. Noor Zaman Khan, and we created a system. We have created some shop floors. We have created some process where he has to fill up some form and then deposit some fee, and then it goes to the some process studies would be done, and then finally it will go to the operator for him to produce that part which it will be used by the research scholars. So this is the overall the scenario of where exactly the present and the future of this machine. And I am hoping that again it's a teamwork from all of us. The whole institute has to come forward, because this facility is not only the baby of the IID center or a few of us, but it has to be a teamwork where the objectives of skill development and training, innovations, students involvement, industry and research are taken together by us. And I hope that the results come as soon as possible, and NIT should feel proud to have such a facility in our campus. I once again thank to the Honorable Director, who has taken a lot of efforts in his procurement. Dr. Noor Zaman Khan, I know the kind of hard work which he has done right from the beginning. Professor Farooq Wani, it was his idea. He actually initiated and told us to bring such a facility. And after his words, we picked up, and Dr. Noor Zaman Khan and myself, we sat days and nights and then worked upon preparing all the specifications, placing the order. I know that we understand the systems are very complex. It's not very easy to get such facilities, but I appreciate the kind of support which Professor Rakesh Saigal has given for not only for this machine, for all the facilities which we have built up in this institute. I thank you all, Professor Sheikh Nazir. He has been very, cooperative with all of our activities. And then all the people who are involved in the mechanical engineering department, in the IIED center department. I'm thankful to Dinesh and Noor who have joined this IIED center last 1 or 2 years, and I really feel that the human resources are being built up, and we are doing something for the local people, local innovators. The colleges and universities are looking at us at us. And the next workshop which we are planning is we are going to invite the industrial people. The director industries of JNK, he already knows about it. And then there are some big industrialists like Himalayan Steel is there. They are also looking for us to invite them. I hope that we'll set a date, maybe another 1 or 2 months, where the industrial houses who would get benefited out of it would be invited to NIT Srinagar, and we would conduct such training programs for them also and tell them about this machine. So with those words, I thank you all, and thank for the participants to regularly joining the workshop, and I hope that there would be a lot of value addition which you are going to consolidate and take it further. With those words, thank you all.
Thank you, sir. Thank you very much for the wonderful and thoughtful message that I have conveyed to the participants. Now, I request Honorable Director, Professor Rakesh Sehgal, sir, to speak about the workshop. Over to you, sir.
Professor Sheikh Nazir Ahmed, Head Mechanical Engineering Department, Dr. Saad Parvez, Head Innovation, Incubation and Entrepreneurship Development Center, Dr. Noor Zaman Khan, Dr. Dinesh, other colleagues from Mechanical Engineering Department, and dear participants. A very good morning to all of you. At the very outset, I would like to congratulate the team from Mechanical Engineering Department, especially Dr. Saad Parvez and his team members, Dr. Rajendra, Dr. Dinesh Kumar Rajendran, and Dr. Noor Zaman Khan for taking this initiative and organizing this wonderful program, which I feel is a unique program, which I don't think that any NIT, must have organized so far. Because I can't even imagine that any NIT will have this kind of, advanced CNC machining center. As it was rightly pointed out by Mr. Hafiz Khan on the first day, on the inaugural session, that we should not call it as a machine. It is a machining center. It can do wonders. It is a 5-axis machine, which can machine any intricate shape, provided you should know the programming. And I'm very happy to note that one day I was just casually, I was walking. As per my habit, I take rounds of certain labs and certain facilities and want to see whether the research scholars and the students, are they really using them or not? Because we are spending a lot of money. It is all taxpayers' money. So it is to be optimally utilized. I was very happy to see that in the afternoon at around 2:30, the session was going on. Somebody was explaining on that machine, how to write the programming and then how to implement that on the machining center. He was, in fact, I didn't disturb him. I just watched it from the outside, and I really felt very happy and very much satisfied that with how much education. It's not only because we are engineers. We don't believe only in theory. Whatever we have to do, it should be hands-on. We believe in the practical implementation of the ideas, of the theories. Until or unless we do that, until or unless we are able to produce the skilled manpower, I will not call it even the manpower. We are not going only for the shop floor people, who are basically ITI degree holders or so, but as engineers, as master degree holders, or even as doctorate degree holders, when we are supervising or we are guiding our students for their doctoral programs, we must know the intricacies of all the machines. We must know the part programming. I understand that all of us may not be interested in any code writing or something like that, but then we should know. We should always know. Then only we can guide our students, more efficiently. So, in my opinion, this program, which was spread over a week's time, and it had 10 theory sessions, and every afternoon there used to be a practical session for 2 hours. I hope that all the participants, they must have gained a lot from this experience. And as Dr. Saad rightly said, that we must organize more such programs, and we must try to utilize this facility 24/7, because 5.5 crore rupees taxpayers money under Prime Minister Development Package, a special package for our institution. So we must make full use of this. We must make as many people as aware. It doesn't matter whether they are from our institution, they are from any other institution, they are from state, they are from even the normal government colleges. Everybody has got a right to upgrade the skills. If we get such interested people, we must always give them the training, and we are all for that. And not only this, we must also give training on our other facilities. We have created electric discharge machining. That is another non-conventional machining part, where we have procured some other equipment and we are likely to procure some more machines. I think we must arrange a training on that also. In fact, as I have a number of times I am telling, whenever we take a batch of the research scholars, the first 1 week should go in familiarizing them with various equipment, especially those equipment which they are using, which they will be using during their research program. So we must make it in foreign. If we go, they won't allow the students or the research scholars to access the lab until or unless they have a certificate of that. They are certified to use their equipment. So we must go for this kind of facility, where the research scholars, immediately after their registration, they should be given 1 week's time, where they should be told what to do, how to use the equipment, how to access the lab, whom to contact, what forms. All forms should be available on our website. If an external agency, they have to pay for the nominal charges for using any facility, it must be available on our website. Like the equipment, the kind of equipment which we have, it's already available on our website. We have already prepared a brochure of that. But nevertheless, we can keep on adding, because we are procuring some more machines, and after 2020 we have procured some more machines. So we must keep on updating that list, and we must facilitate. If for an outsider, it must be very easy to access our website, our facilities, and he must know whom to contact for which facility. So that kind of arrangement, I hope that the young faculty members in mechanical engineering department, they will take this suggestion very seriously, and they will work towards that. And with these words, I would once again like to congratulate all the team members from mechanical engineering department, IIED center, and I would like to thank all the experts from industry, from IITs, from NITs, and from other institutions who have contributed in providing skill sets to the participants. Thank you very much.
Thank you so much.
Thank you, sir. Thank you so much for the wonderful words, and we'll definitely take your words and try to implement what are the things you have done. We'll be working on it and doing it in upcoming days. Finally, it's time to conclude the session with vote of thanks. I, Dr. Dinesh Kumar Rajendran, the program coordinator of self-sponsored high-end workshop, is here to deliver the vote of thanks. I would like to express my gratitude to the Honorable Director and patron of the workshop, Professor Rakesh Segal, sir, for encouraging us throughout the journey to complete the workshop successfully. Thank you very much, sir. I'm thankful to register and co-patron of the workshop, Professor S.K. Bukhari, for constant support to execute things in a smooth and effective way. Thank you, sir. I would like to express my thanks to Dean RNC and Chairman of the workshop, Professor M. F. Vani, who always inspire us by proving age is just a number with his projects and research. Thank you very much, sir, for motivating us. I would like to express my heartfelt thanks to Head Mechanical and convener of the workshop, Professor Sheikh Nazir Ahmed, who always stand with us with a positive note in all our steps that we march towards success. Thank you very much, sir. I would like to express my gratitude to Head IDC and convener of the workshop, Professor Saad Parvez, a very dynamic and a personality who tries every possible way to develop the entrepreneurship and the startup by supporting the innovators of the valley and to make a better career for most of the innovators in the valley. Thank you very much, sir. I would like to thank my co-coordinators, Dr. Moshin Khan, Dr. Noor Zaman Khan, Dr. Abhijit Day, and Dr. Deepak Kumar Nayak, who always extend their support throughout this week for making things so smooth, and especially the faculty members and non-teaching faculty members of Department of Mechanical Engineering, who are always supportive in this journey. I would also like to thank the professors who deliver the lecture and make this workshop so lively and place of technology transfer. starting from the Chief Guest Engineer Abizullah Khan, Dr. Sajan Kabir from IIT Guwahati, Dr. YG Bala from MNIT Allahabad, Dr. Batin from GCE Salem, Dr. Muthukumaran from NIT Trichy, Dr. Shiva from IIT Jammu, Dr. Amrut Mulai from SVNIT Surat, Dr. Noor Jamam Khan, and Dr. Saad Pravesh from NIT Srinagar. I would express my heartful thank to Engineer Nadeem, the one-man army, what I ought to call, because he is the one who was completely handling the training session. The afternoon to us, it was like he was completely making it more interactive and lively, and it was so effective that even virtually we could train the participant with much of interest. Thank you very much, sir, for all your efforts. I would also express my heartful thanks to the our research scholars and the organizing team, Ms. Kurat, Mr. Irfan, Mr. Sahid, Mr. Tariq, Engineer Shahrukh, and Mr. Irfan for managing the event in backend, like which without them, like, would not be that easy to handle this 1 week complete session into a grand success. I will also express my thanks to the account departments and administration for their heartful support whenever we require. Finally, I would like to thank the participant. Without you people, this session would not be this much successful, and without all your interaction, we would not be getting things. And we assure that this would be the final slot for this online session on this. So as sir said, like we'll be starting with offline section and training program as well. With this thing, I, Dinesh Kumar Rajendran, signing up from this 1 week high-end self-sponsored workshop on 5-axis CNC. See you all soon. Thank you very much.
Thank you, sir. Thank you so much.
Thank you.
Thank you, sir. Participant will be floating the form in the group. You can just fill it over there.
Yeah, I think
Thank
feedback is very important. I
Yes.
would request to generate and obtain the feedback forms.
Yeah, sure. Thank you, sir. Thank you.
Okay, thanks. Thank you.